What if you could fall into a black hole and survive, at least for a moment? Would you see the future of the universe? Or would space and time themselves tear you apart before you even realize what's happening? Black holes are often described as cosmic monsters, but in reality, they are precise consequences of Einstein's equations. To understand whether entering one is possible, we must first understand what a black hole truly is. A black hole is not an empty hole in space. It is a region where gravity becomes so intense that nothing, not even light, can escape. This happens when a massive star collapses under its own gravity at the end of its life. The mass is compressed into an incredibly small volume, creating an object with extreme density. The boundary around a black hole is called the event horizon. Crossing it means there is no return. But surprisingly, at that exact boundary, you wouldn't feel anything special, at least not immediately. Before black holes were ever photographed, they existed only as equations on paper. In 1915, Einstein published his theory of general relativity, describing gravity not as a force, but as the curvature of space-time itself. Just 1 year later, physicist Carl Schwarzschild found a strange solution to Einstein's equations, a region where space-time collapses infinitely inward. At the time, even Einstein believed this was a mathematical curiosity, not something real. For decades, black holes were considered impossible objects. There was no way to see them directly. After all, they emit no light. Everything changed in the 1960s. Astronomers began detecting powerful X-ray emissions coming from invisible objects in space. These objects were pulling matter from nearby stars, heating it to millions of degrees before it disappeared. One of the most famous discoveries was Cygnus X1, identified in 1964. It was the first strong candidate for a real black hole, not theoretical, but physical. Then, in 2015, something extraordinary happened. Scientists detected gravitational waves for the first time, ripples in space-time caused by two black holes colliding over 1 billion light-years away. This was direct proof that black holes exist and merge islandly. Finally, in 2019, humanity saw a black hole. The Event Horizon Telescope captured the first ever image of a black hole's shadow at the center of galaxy M87. It was not a hole, but a glowing ring of light, matter orbiting the point of no return. At that moment, black holes stopped being invisible monsters of theory. They became observed objects of reality. From far away, an observer would see you slow down and fade as you approach the event horizon. Time appears to freeze for you. But from your own perspective, time flows normally. You would cross the event horizon without noticing a sharp boundary, no wall, no sudden explosion. This is where black holes become truly strange. Space and time swap roles. Inside, moving forward in time is as unavoidable as falling downward. As you fall deeper, gravity becomes uneven. The force pulling on your feet is much stronger than the force pulling on your head. This process is called spaghettification. Your body would stretch vertically and compress sideways, not because of speed, but because gravity changes drastically over short distances. For small black holes, this stretching would happen before you even cross the event horizon. For supermassive black holes, you could cross the horizon safely, but not escape your fate. Inside a black hole, all paths lead to the center, known as the singularity. The singularity is not just a point, it is a breakdown of physics. Our equations no longer work there. Density becomes infinite and space-time curvature becomes extreme. Some theories suggest black holes could connect to other regions of the universe or even other universes. These hypothetical tunnels are called wormholes. However, no experimental evidence confirms their existence.